This is an ultimate quick start video that will teach you everything you need to start work with Joint and Joint Native. Joint is a framework that lets you create every possible dialog production, for example, simple and basic things like waiting skips. But, as you can see, it also supports networking. Make and attach modules called Fragment to intuitively build up complex dialog scene. And you can make crazy dynamic dialog productions that controls the gameplay. If you want to learn more, you can check out our showcase video for the plugins, link in the description, so take a look. Then now, let's start off. Let's start off with installing Joint. In Epic Games Launcher, go below to pep library and find Joint. Install Joint for your engine version. And after that, open your project, go to Edit, Plugins, Conversation, enable Joint and restart. Then now Joint has been enabled. Now it's time to install Joint Native. Visit GitHub page for Joint Native, link in the description. Press code, download zip in the menu, or you can clone it if you want. To your project directory, usually under documentation, all your projects, and make a folder named plugins if not present, and put extracted folder of Joint Native there. Once finished, open your project, you get a pop-up like this, just press yes. Then you will have your project with Joint and Joint Native. It's not done yet, go to the project settings, visit gameplay tags and find gameplay tag table list, add a new element on it, and fill with DT joint sample gameplay tags. Then it's done. Then now let's hop in the real game. I opened up a new empty level with just some basics. You can also open one to follow along with. Do right click on the contents browser and find dialog section and select dialog manager. Do double click on the dialog manager asset to open dialog editor. So this is the graph where you can build up your dialog production. To start off, first thing you have to do is making a new foundation node. Do right click on the graph and select foundation and scale it as you want. Foundation node is a frame for node called Fragment, which are data or action you can put on your dialog. For example, in such dialog, line of characters, images can be implemented via Fragment. And normally, one foundation node will be used to build one line of your character. Thus, we call foundation node as unit of dialog as well. Anyway, we're going to start off with very simple dialog production. Goes like a player say hello to the NPC, and also NPC says hello blah blah blah. So let's add one more foundation for the second line as well, because we want to display the line separately. And let's connect those foundation nodes real quick. Next thing to do is attaching text and text style fragment on the foundations. Select one foundation node and go to the fragment palette on the right corner and select text. Then you will see a text fragment attached on the node, and let's also add text style fragment as well. So when you want to attach fragments, you can do it either with the fragment palette, or you can just right click on the node and go to the add fragment section and find and select one from there. So we added all fragment types we need, so let me just copy paste the text fragment here. So looking good. Well, to briefly explain, text fragment is a fragment that contains a text, literally. It can be used in multiple situations since it's a pure data, but especially it's mostly used to display text line on the dialog widget. And text style fragment is simple. It contains a text style table, and text fragments can use a table inside it, so that's the usage. Now let's start to write down some lines there. Looking good. Next, let's feed the text style fragment to the text fragments to start off styling the text. But before that, let's specify the text style table to use. Select text style fragment and specify DT joint sample text style table on text style table property, then it's done. And here comes the magic. Select both of the text fragments, find text style instance property, and you will see that drop a button there. Press it and select the text style fragment we have. Ta-da! Those text fragments took the reference of the text style fragment. You can hover your cursor over the property to highlight the node it refers, and also you can pick one with the drop button as we saw. And also you can quickly jump to the node it refers with that arrow button. It's a feature called node picker, and it works with any node in the same graph. Crazy thing is that you can also make your own fragments use this feature with fdialog node pointer structure as well without extra outputs. And you might have noticed that a little toolbar on the text fragments have showed up after the node picking. That's our WYSIWYG editor for the text fragment styling. You can select the style you want to use on the selector and select the part where you want to apply style and press Ctrl-Shift-S. Now your text has been styled. And you can also use the dropper button to pick the style from the text. And you can also edit the raw text with the low rich text decoration with that icon. Anyway, I think our dialog looks kinda ready, so let's test it out on the level. Since we need something to start off the dialog, so let's make a button actor that plays our dialog when it's been pressed. I've already prepared an actor that looks somewhat like a button, consisted with 2 static meshes for visual, and with a little box collision that will detect the overlap. Let's add a logic that plays the dialog on the overlap event. Search for create dialog. Put a fin from there and promote it to a variable. We're gonna put our dialog manager as here to make it play. So don't forget to mark it as instance editable. Put a fin from there and take the dialog instance that has been created. Find start dialog and place it. It's done, but I also wanted to add a little sound cue on the button press and organize it a little, so I did it. Let's place the button and feed our dialog manager and see. It seems like it's doing nothing. Well, let's check out whether our dialog is being played correctly with Dialog Debugger. You can press F9 to toggle breakpoints on the nodes or fragments, or you can right-click and select Add Breakpoints and toggle breakpoints to plant one. Now let's see whether the breakpoint is getting triggered. Oh, it's being triggered. And that means that dialog is getting spawned very well. If you press F10, F11, F12 to step out, step in, step over the playback, you will see that nodes and fragments are being played correctly as well. Speaking of which, with Debugger, you can also see and change the variables on the fragments in runtime for the test, so use it as well, it will help you a lot. Okay, then now we know that our dialog is being played very well, since it's hitting the breakpoint, then what could be the issue? Problem here is quite simple actually. It's because we didn't make a dialog widget that will display the dialog. So let's make one for us. Select the root node and search and place dialog widget. There's a reason why we're adding it on the root node, it will be explained later. Dialog widget fragment is a sample fragment that contains and creates dialog widget for the dialog instances. Well, we call it sample, but it's because the widget is additional thing in the framework, thus it does not mean it fell short. It has really strong features and enough to be used in actual products, so feel free to use them. Anyway, let's go back and check that create if not present parameter. We'll let it create and attach dialog widget for us automatically. So great. By the way, you can also make your fragment expose variables on the widget like this. To use this feature, open your fragment blueprint. You can visit it with this button. Visit class defaults. Find a property named property data for simple display on the graph node and add a name of your property there. Then it will be there. It will help you a lot when you want to quickly identify each notice edge or when you want to quickly edit your nodes. Anyway, let's test it out again. Now it's being showed up. But somehow it's just immediately closed itself, so let's fix that as well. But before that, I have to explain the reason why we attached dialog widget fragment on the root node instead of foundation node. We call such fragments on the root node as manager fragments. Manager fragments will be treated as being attached on the dialog manager itself, thus they will stay active and available through the whole dialog playback. And since we want to make our dialog widget available throughout the whole dialog, so it's best to make it as manager fragment. And because of that, it's the best place to put fragments with shared data in the graph. Well, something like text styles. So we better drag and drop the text style fragments to the root node as well. Like this. Now let's go back and fix it disappearing immediately. If you check out on the debugger, you will see that it's moving on the next foundation without stopping or halting. And we don't want that to happen because we want to make it wait till the player skip. So we have to insert something on there to halt the playback for the player skip. So what are we going to do now is, well, selecting this node and placing wait skip fragments. So wait skip fragment is a fragment that will wait till players to send a skip request while halting the playback and preventing it goes like. So let's copy paste it on here as well and try this again. See, now it's halting the playback until we skip. It's great, but we didn't make a way to send skip yet. Thus we cannot skip it, we get stuck here forever. Well, we want to move on, so let's find the info for the skip action. Well, you can do this anywhere, but I will use the player controller. Place input for keyboard X. Well, I genuinely don't recommend to use this input system on the actual product. It's just for the showcase purpose, so please just use enhanced input instead. Next, call get all dialogues. Attach for loop for each loop, and for the fin, and find send gameplay event to actor. So when we press X, it will fire a gameplay event tag to the all dialog instances in the world. Well, it's only for the showcase purpose. You might need more clever way to do this. And that tag we have to send should be matched out with the tag that wait skip fragments will wait to receive. So just copy the tag and just put it in here. So great. Now start the dialog again, press X, then next foundation will be played like this. Finally we got something that can be called as proper dialog. Well, let's continue. Next step is to specify participants of the dialog. Just before that, I have to let you know that you can press Ctrl F to open such tab, Ctrl H to replace tab in the editor. You can just find any data with its name or value of it, and also query them with their tag, or edit them as you want on here. And also replace all the tags at once. This is useful when you want to change the name of things. And not only in a single dialog manager, you can also search and replace among multiple dialog managers. So we have two participants on here. One is for the player and one is for the NPC. So we're going to use two participants fragments. Search for participants and press participants twice. There we go. In Joint Native, we uses gameplay tag to identify each participant. So you have to make and provide participants tag for your participants. So let's make new tags for them. I will add a new sample tag on the joint native.participant and name it joint native.participants.sample.mpc1. And I will provide a tag on the participants tag property of our participants fragment. And also I will do the same thing again for the player. Joint native.participants.sample.player and feed it. Great, now it's done on the grep side. Next thing to do is attaching participant components that represent the participants in Joint Native to our characters, and also we will attach some good participants related components as well. Go to the player character and add dialog participants component, and also add BP joint participant widget visual and BP joint participants widget render socket as well. Next, we are going to specify the player participants tag for every component we added. Select components and find the participant tag property and specify the player participant tag we added, like this. Do this for other components as well. By the way, there is a reason why every component has individual participant tag container. It's because one actor can sometimes have multiple participants. For example, a character with multiple heads, or a character with split personality with different voices can have multiple participants components. Anyway, go to the participant widget visual component and specify the display name as you want and also the text style table for it. This display name will be displayed as the name of the character on the widget. A little final touch, go to the viewport and drag that widget render socket to above the character to make the widget displayed above the player's head. Now the setting for the player participants is done. we still have one last thing to do. We didn't specify the speaker and listener at a time yet. So search speaker and listener fragments and attach it. Speaker and listener fragment is a fragment that contains the data about which participants are currently involved in the conversation. It's just a pure data fragment, it doesn't do anything by itself, but the widget and components will pick it up when it's played and use the data inside it for their action. Anyway, let's add new elements on speakers and listeners property, and pick player participants fragment for the speaker and NPC for the listener, even though we didn't add the NPC and participant on the level yet. Let's move it to be the first fragment and copy paste it on the next foundation as well. And swap the speakers and listeners to make the NPC speaks to the player. There we go. All participants are provided properly, so let's test it out. Now you can see the player's display name we set on the component is being displayed, which means the widget successfully found and used the visual component for the participant tag. If we see the line of the NPC, it's of course not showing the name yet, because we don't have NPC in the level yet. So let's add an NPC as well. Go to Plugins, Joint Native, Sample, and find BP Bird, place it, and provide the NPC tag we created for all the related components as well. Finally, change the participant's display name to Bird. Then let's see the results. Now NPC participants works as well. Well, it's good, but it's too boring to see a dialogue fixed in the middle of the screen, so now let's make it follow the participants. Extend the loot node a little to make some place. Add dialog widget locator, and also select dialog widget locator start following speakers. Dialog widget locator is a fragment that calculates and changes the widget transform of the dialog widget, and the other one is a fragment that makes that locator to start follow the speaker. And make sure to fix the dialog widget in the dialog locator and dialog locator in the start following speakers. Make sure you fix the correct one for each. One more thing, this is not necessary to follow, but I will attach sample provide dialog aim offset to participants fragment as well. This will provide some necessary data on aim offset to the participants, allowing their body to follow the characters in the dialogue. By the way, can you see how beautiful this node is? You can customize the color of your node and change the icon of your fragments with images and UI materials, so try them out and go crazy. Anyway, let's test it out again. Now the widget is following the player's head, and also you can see the NPC keeps looking at us like this. If you skip to the line of the NPC, you can see the widget is following him as well. We have one more thing to think of our participants. As we saw, our participants fragments collect the reference of the participants component in the world automatically, but what will happen if there are a lot of actors that have the same tag? This can be happening quite frequently. Every runtime spawned enemy pawns, characters for multiplayer clients would have the same tag. In such cases, you can't layer on the automatic reference collecting because they are not unique anymore. Third, sometimes you must manually specify which participant's component is actually referred by your participant fragment. So let me show you how to do this with our player participants. First, let's open the button blueprint where we create our dialog instance. Break it and expand it. For the theme and type, get dialog manager. With this function, you will grab the runtime instance of our dialog manager asset. And from the dialog manager object, let's call find manager fragment with tag. To specify the participant manually, you must be able to access the participant fragment outside the dialog manager, and the easiest way to go is attaching a special tag on your fragment and calling it for the tag to get it. For that, let's make a new tag called joint native special node tag sample player participant and put it here and copy the tag. And put the tag to our player participants fragments node tag property and go back to the button. Since we can now query our player participants fragment with this function, now it's time to get the player phone and fit it to our fragment. Cast to df participant and set participants component instance Well, it's the property for the participant component that it will use. So we grab the participant component from the player pawn and fit it there. Get player controller and get controlled phone and get component by class. Make it query for dialog participant component and plug it there, and it's done. Now finally, go back to the dialog manager and uncheck allow collecting participant component on the world automatically. Well, actually it doesn't matter that much because you won't collect it when it already have one, but just to make sure. So if you see the result, now it's working with a component that has been manually specified. Actually, well, yeah, we can't tell the difference because we specified the same actor anyway, but this will shine in the later part of the video when we go into networking sessions. This part is very important to understand. The next thing we are going to learn is about the playback concept of joint, and we are going to learn it through making a cool dialogue with level sequences. So for the level sequence, I added NPC2 and also created very simple level sequences as well. So let's start off. First, I will just move the previous nodes away and copy paste the first foundation here. Expand it a lot for extra fragments. And now add spawn level sequence and wait level sequence and fragments. Insert the spawn level sequence after the speaker and listener and change the text content. And since we want to make it wait until the level sequence to end, and then require skip linkage after that, so move the wait skip fragment to the tail. And now let's provide the spawn level sequence fragment to the wait level sequencer to end fragment to let it know which level sequencer should it wait for, just like this. Next, let's go to the playback setting of spawn level sequencer and check autoplay, and also specify the level sequence to play as well. Then the first sequencer part is now done, and basically the second sequencer part is exactly identical. So let's just copy paste all of those nodes like this. Oh, the order is a little messed up, let me fix that. Change the text. And also don't forget to change the target spawn level sequencer of the second wait level sequencer to end fragment, because it will be referring the first one yet, and we want to make it wait for the second one instead. And also I modify the speakers and listener to make it fit better with the level sequencer a little bit more. And let's check out this again. So it will go like, the sequencer will be played first and the text per sequencer will be displayed, and it will wait to that sequence to end, and after that it will wait for the player's input, and it goes the same with the second part as well. So it's finished, but it's too hard to see in a look, so I will stove some of the nodes to make it look clean. Select the fragment and go down to the detail panel and change the slate detail level to stoved. Then it will look much better than previous one. Now let's see the result. Oh, well, something is off. If you see the text, you will see that it just immediately plays those two texts at once, and that means those fragments that should halt the playback aren't working properly for some reason, and we don't want that to happen. So let's see what is actually going on inside. Place breakpoints and play them again. Now let's listen to the session. Oh, did you see that? All of the notes have been started to be played at the exact same time, unlike we expected it to be played sequentially. And it's actually a totally normal behavior, and you must understand this. By default, fragments will be played simultaneously. It's useful because it lets us make each fragment work like as if they're in an individual playback track, and that's quite useful in most cases. For example, if you want to make the server and clients play different fragments, you can just simply make 2 tracks for each like this, which looks very easy and intuitive. The question is, what should we do when we want to play the fragments one by one sequentially? The answer is quite simple, just use sequence fragment. So let's attach one. As it tells with its name, sequence fragments is a fragment that place its sub-fragments one by one. So the only thing we have to do to make them played sequentially is just attaching fragments onto the sequence node here. So by the way, I didn't tell you about this earlier, but you can also specify the direction of the fragment. Works best with sequence fragments. Just look how clear it is. Anyway, let's just move all of them. And done. Before testing it out, I realized I provided wrong, so I changed it to have the right one. Make sure you also provided the right one as well. Now it's the moment of truth. And it's working as expected. Great. One last thing, if you felt like it's too long to see in a look, you can use multiple sequence fragments to make it look more organized. It will just work the same. Now you've learned about the basic playback concept of joint, and also about how to use sequence fragment as well. But well, here's one secret. Even though we told it as playback concept of joint, but it's not an absolute rule, because joint let you override this behavior as you want. But many existing fragments follow this rule, so it still works to understand. This will be discussed in details in the later part. Next thing we are going to learn is how to make user selectable branching like this. It's simple, we gotta use both and select fragment for this. Both fragment is a fragment that does internal calculation with branching, and select is a fragment that represents an option on both fragment. Let's try them out. Place both fragment and select fragments as well. So duplicate select fragment to make it 3. You need wait skip fragment here, remove that, and place both fragment on the place. Next, place text fragments on the select fragments. They will be displayed on the option button. The button widget only supports text fragments by default, but you can easily customize it to support whatever you want. So anyway, let's fill out some reasonable text there. And fill out the text on the select fragments. Great. And I did some homework, just place some more nodes to make it more convincing. I just wanted to make it both again when users chose excuse me option. So for that, place connect node here. It literally connects nodes in the separate places. In this case, we will use this to recursively leave the first both node itself. Last thing you must make sure to do is, whenever you are using select fragments with text fragments, to put joint native.widget. Don't display with basic logic tag on all the text fragments on the select fragments, because otherwise the widget will display the text on the option button in the main text block as well. And you can prevent that with that tag. Last thing to do, you have to uncheck use portable player in the both fragments. But this change is only for the showcase purpose. In real product, we recommend you to specify the players that can bolt on it. We are going to talk about this in the next section of the video, so please continue watching this video. Now let's see how it looks like. Oh, it's showing the available options and letting us pick one. But if you try to pick it, you can't actually pick it yet, because we need to patch an interface in the player controller to make it work. So opening first, open the player controller named BP joint sample PC in plugins joint native sample as well. In BP joint sample PC, you will see those event blocks. We are going to copy it to our player controller, but first, let's make our player controller inherit the aforementioned interface. In class setting, find implemented interfaces, such BP joint net authority handle interface, and select that. Now if you go to the function override menu, you will see interface double request both selection event has been appeared. So select that. And copy the logic we have in the sample player controller and paste it on our player controller. Just press confirm, remove that, bring the event here, remove this as well, and call this event here. And connect the parameters and pins. If you test it out, now you can finally select one. And although both fragments seems working well, try this out yourself. Next thing to show you is also about the branching of the dialog, but this time we will branch the dialog with conditions instead of user inputs. This time, let's try to branch the playback to each of those 3 nodes, according to whether each of the bird has been destroyed or not in runtime. Search branching and place. Be careful to not use branch, that's a legacy one. If you place it, you will see that 2 pins named true and false have been showed up. Then we are good for now. Now we need condition fragments for this branching fragment. If you search for condition, it will show you all the condition fragments available. Now, as you might guess, we implement the condition test that the branching fragment uses on the playback branching by attaching and combining condition fragments on it. So let's try it. First put condition end, and also 2 condition check is actor valid. Each of them will be used for each bird, checking whether they are still there or not. So let's feed each bird to those condition is actor valid fragments. Go to the detail tab and find actor property, press drop button, and pick the bird, and do it for the next condition fragment with another bird as well. As you can guess from its look, it will play the nodes at true fin only when both of them are still there. So let's connect the nodes that say hello to both of them on the true fin, and let's connect the nodes that say where did they go at the first pin, like this. And let's test that out. Okay, now you can see that it's playing the node at the true fin when both of the birds are alive. But if you remove one of them and see, oh, it's still playing the node at the true fin. Why does this happen? Actually, this is quite a common mistake to happen. If you see this in the debugger, you will see that at the time that text has been displayed, our branching fragment has been played already. So it had already checked out the validity of the birds and also has decided where to move on. And we removed the bird after that, thus it's not affecting it at all. So if you want to make it decide where to move on the moment right before we take off, we have to put branching fragment under the sequence node after the wait skip node like this, making it to be executed in the final moment. This is why you have to understand the concept of sub-fragments simultaneous playback, and also why you have to consider on using sequence fragments on the production as well. So let's play that again. Oh, it has been disconnected for some reason. Let me just fix that. See how it goes. Going well on true fin. Now let's remove one bird and see. Oh, it's playing the node at the false pin as well. You can also use multiple branching fragments together to make complex branching as well. For example, let's say we want to detect when only one bird has been disappeared and play a different line for that. What you have to do is just placing another branching fragment there and unchecking use pause property of the first branching fragment. As soon as you do that, you will see that pause pin of that branching fragment has been disappeared. Here is a visualization of how it works. If it uses pause, it will work like if-else statement with the return. As you can see, it prevents the other branching fragments to provide their nodes on the system. If you uncheck use pause, it means that it doesn't return anything when it fails, letting the other branching to return their nodes. Because of this, you can attach as many as branching you want to use to make even more complex branching for your dialog. While explaining this, I set up some second condition test to play different dialog when only one bird is missing. It's similar from the last one, but I wrapped each is actor valid conditions with not fragment and wrapped that with and condition to check out whether both of the birds are removed or not. See the result now. Good. It's playing the line for the only one bird and also no bird at all. Cool. We have one more special thing to talk about and condition fragments. When its property named use asynchronous playback is checked, it will play its sub-fragments one by one just like sequence fragments does. But the thing is, it will stop iterating whenever any of the fragments fails. Thanks to that, you can make some conditional fragments that will be played in only certain conditions. For example, in this node, the text fragment with text both of you will be played only when all the birds are there, and where did it go will be played only when both of the birds are gone. So just go crazy with it. Joint Native has a lot of other fragments as well, but we are not going to take a look into one by one because they are really straightforward to use, so they don't need explanations. Instead, now we are going to see something more interesting. Now we are going to see some of the existing fragments that support networking. Well, you can make your own fragments support networking as well, but we are not going to take a look into that. But there will be a documentation page for this on the official website, so check out if you're interested. First one we are going to see is wait skip fragment. You can use wait skip fragment to halt the playback of the dialogue until all players agree to move on to the next node in the networking based multiplayer game. What you have to do is quite simple. Just go to your wait skip fragment and check wait until all players skip. Next, select the fragment and go below to the detail tab and check replicate. This is necessary for every fragment that supports networking because otherwise it won't replicate the properties, and also it cannot use RPC functions. Next, we have to specify skippable players to it. This should refer to a valid players fragment. Add a players fragment on the root node. There we go. It's basically a container fragment for the player controllers, and it can be used in multiple situations, especially like when you want to specify the players that can interact with your dialogue exclusively. Now it's time to add grab players fragments as well. It's simple. When it's played, it grabs all the players' controllers in the world and peers it to the specified players comp fragment. If you need to specify controllers manually, just access it from the outside and feed the controllers, just like we did with participants. So let's feed the players fragments here and go back to the wait skip fragment and select our players fragment. Now let's test it out. Before that, we have other things to do outside the dialog manager. First thing we have to do is to change the logic of dialog creation in the button blueprint to make it support network sessions. It's simple, just add one custom event and set this event's replicate mode to run on server and make it reliable. Next, take the logic on the on component begin override and attach it on our new event instead. And lastly, place an event call to our new event on the override event. Next thing to do is attaching new logic that handle network side logic on our player controller. So open the sample controller in the plugins joint native sample and just copy paste those functions and remove that and execute event below and connect pins, and it's all done now. Also make sure to add more players from the menu, and also make sure to change the net mode to listen server or client. Finally, it's moment of truth. Well, let's press X on the client on the left. Then you will see that player skip counter on the bottom has increased, and if you press X on the other clients as well, the wait skip node has finished and moved on from there. How cool is that? And let's see another cool fragment that supports networking. Well, it's both fragment. You can make multiple players do kind of both for the next branch to go. Actually, that's why its name is both, because we initially designed it for the multiplayer sessions. To make it work, go and provide both of the players to it and check use both of the players. And lastly, check replicates. You also have to implement the both relate function from the interface on the player controller. But we actually already did this in the previous part, so it's all done at the moment. Well, let me put some flashes on the bond here. Now let's test out the results. Players select options they want, then both timer starts. And they can also withdraw their boards and change it. And if you get some tiled options, it will make a new board with tiled options. And finally, when one option got the most lates, it will be chosen like this. One last thing to show you is how to specify the participants for each players in the multiplayer games. It can be done in many ways. One of the ways is just using different tags for each participants and players, just like we did for the NPC bird characters. For example, in games like Overwatch, you can provide participant tag for each players, something like joint native participant Lionheart, Tracer, and Mei. But if your game is something like MMORPG, so every character cannot have its unique tags, then each participant must be specified manually in the dialogue. We actually did this already, and it only needs some tweaks. Just copy paste your player participants fragment like this. Use the participants fragments for the second player in your dialogue. Next, go to the button where it creates our dialogue instance. What we have to do is just taking all of those player participants fragments instead of just one and fitting each player controllers there. For that, use find manage fragments with tag. Copy paste that tag from there, pull each loop and connect everything, and use that array index on getting player controller from index, then it's done. If you test it out, you will see that dialog widget is following each characters between each node, and it tells us that both player controllers have been successfully provided to the dialog as participants. Finally, here comes the fiesta resistance. In this chapter, we are going to learn how to make our own fragments. For explanation, we are going to use this apple box actor. Apples get inside, the count rises, and it also has a function that spawns an apple above. Just like this. We are going to make two fragments that work with this box. One is a fragment that make and display a little interface on the widget where a player can spawn new apples, and one another will be a condition fragment that checks whether we have enough amount of apples inside a box. And after that, I will also quickly show you how to make a fragment that can access and control children or descendant fragments, with one more sample fragment that automatically formats descendant text fragments with the data we want. So let's start off making the apple box fragments. To make new fragment, go to the toolbar in the Dialog Manager editor, press Create Dialog Asset and select Dialog Fragment. Editor tab for our new blueprint fragment will pop up. Before start off, let's rename the fragment to df apple first. Now place the fragment on the graph, search df apple and place it. There's our boy. And let's place it on the sequence fragment. And let's go back to the fragment blueprint by clicking that button on the detail tab. Great, now let's finally start off. First, we need a reference to that box in the world. So let's add a soft reference variable for the ppf box. And don't forget to mark it instance editable. Next, let's add an event that makes our apple box spawn an apple. Place a custom event, rename it to spawn apple. Place apple box reference here, resolve. Call spawn apple. Good. Now, since we're going to attach a new user widget to the dialog widget, we have to take the reference of the dialog widget fragment from the graph. And that can be done with the node picker feature. For that, let's add a new property, name it dialog widget fragment, change its type to dialog node pointer. Go to the default value, add a new element on our type and fit it df dialog widget. Well, adding such restrictions will help you to prevent possible mistake and also help your teammates to understand the requirements of your fragments as well. Anyway, go back to your dialog manager and pick the dialog widget fragment with this. Nice. Now it's time to make the part where it creates a custom widget and attaches that on the dialog widget. For that, we have to override events on its life cycle. So press override, then you must say, damn, what are those? Yep, those are things that you must understand to use joint like your arms and legs. But don't panic, I will let you know which one does what. But also, I gotta say, this one is a little tricky to get it when you first hear this. So if you don't get it in the first time, just take your time and rewind it as many as you want. And you can also take a look into existing fragments for learning materials as well. So first of all nodes in the graph, including foundation and fragments, have three states on its playback: active, pending, finished. Active state means that your program is executing its own task and not ready to be finished yet. Pending state means that your program can be still executing its task, but it finished its necessary task already and ready to be finished anytime. Finished state means that your program is inactive, not working anymore. Let's see how the state of nodes are getting changed in the actual production. First, let's say this foundation node has been started to be played and became active. In joint, we call the event that nodes are becoming active as node begin play. When a node is begun played, by the default implementation for node begin play event, it will perform such actions which are 1. If it has any valid subnodes, play them as well with subnode begin play. And second, if it doesn't have any valid subnodes, it will just simply finish itself. Since our foundation has subnodes, it will play them. In this case, onServer, speaker and listener, and sequence fragments will be played. So onServer fragments will be played at first, and the onServer fragment will play its subnode before the speaker and listener fragment starts to be played. So the spawn level sequence fragment will be played at next before the speaker and listener fragment. If you are familiar with programming concepts, understanding it as having pre-order, traversal order will help you get the concept. And well, the spawn level sequence fragment has an immediate action, so it must be designed to be immediately finished on the begin play event. And since it has been finished, its parent node, onServer fragment will be marked as pending state as well. This behavior is done by pending chaining system, and we will learn about this shortly after. Anyway, let's move on. Now the foundation will continue to play other subnodes as well, which are speaker and listener, and the sequence fragments. So speaker and listener become played, and fragments like this that has no special action by itself will be finished right after the begin play due to the default implementation of node begin play. So this fragment will be finished right after. This will be applied to many other fragments as well, especially with data fragments. Now the sequence fragments will be played, but sequence fragments work quite differently from the other nodes. Sequence fragment plays its subnodes one after one while waiting the previous one to be marked as pending instead of playing them all at once. Sequence fragment achieved this by overriding the default implementation of node begin play event and adding custom subnode playback logic there. And this is the way exactly you have to do to implement fragments with dynamic actions. You have to override lifecycle events like node begin play and put your desired action there. And that's why it is so important to understand how the node states are getting changed in the playback, because you have to know the timing for each event. So right, our foundation node just finished playing every node on itself, and it's time to see what process the foundation node takes to be fully finished. To make the foundation node to end and move out from it, we have to either mark the foundation node as pending or finish it by pause. And here the aforementioned pending chaining system comes in. Pending chaining is a system that tries to mark the parent node as pending as well when its child is marked as pending. Let's see how it works. Let's go back to the moment when this text fragment got played. Well, as we saw earlier, the text fragments will begin play the sustain fragments on themselves. Well, sustain fragment is a simple fragment that keeps being active for only specified duration and become finished after that. And let's say the time has passed by now. So due to that, our df sustain will be finished. But when a node gets finished, it will be marked as pending state automatically before it becomes finished. And we call the event where a node gets marked as pending as node marked as pending event. And this is where the pending chaining system comes in. When a node is marked as pending, it will trigger mark node pending if needed function of its parent node that will try to mark the parent node as pending by the condition. The way how the function works is simple. It will mark the node as pending if the function check can mark node as pending returns true. And by default, the function check can node mark as pending will return true when the node has no subnode in the first place, or when all its subnodes are marked as pending. So in this case, by the second rule, the parent node will be marked as pending as well. And this is how the pending states are being propagated to the parent nodes as well. And this is the way joint used to shut down a production from the very bottom level to top and eventually foundation node itself. Oh, by the way, you can still override check and mark node as pending to prevent your fragments getting marked in pending in unwanted situations. This is especially useful when your fragment has some specific important action that must not be cancelled by pending chaining. Great! Now let's see the moment where the foundation node becomes pending. The text fragments will be flayed and become pending and finished. And lastly, the wait skip fragment will be flayed and follow the same process. And after that, sequence fragments will be marked as pending since its subnodes are now all flayed. And finally, the foundation node will be marked as pending as well because all of its subnodes are marked as pending. Now we are on the very last stage. When the foundation node is marked as pending, it will be finished automatically. And we call the event that a node becomes finished as node end play. We skipped explaining this in the earlier parts, so it might confuse you a little, so I gotta say this. Not only the foundation, but all fragments will trigger this event when they finish. And like node begin play event has, it has default implementation on the event. It calls subnodes and play function to finish all the children nodes that are not finished yet. And just like the subnodes begin play, it will be propagated to all the nodes down to the bottom with the same pre-order traversal order. In this case, the on-server node will be flayed at first, and the sequence comes next, and the text fragment on the sequence node ends at the last. And after that, the dialog instance will find the next node to play and move on to there. One last thing to mention, so as I said, you have to override those events to implement new behavior for your fragments, and actually those events are divided into two different events. They all have pre and post versions instead of one. The difference between them is quite simple. It's about whether they will be executed before or after the notification delegate broadcasting, which are the delegates that any other external objects can use to acknowledge the changes on the state. Pre-events will be executed before any other objects or nodes or widget etc. notice that state has been changed, so they are a good place for pre-processing. And post-events will be executed after that, obviously. They are good for the general purposes. You can put actual actions or etc. Especially those should be the place where you put subnode related logics, because if you do that in the pre-events, the order of the state change, delegate notification will be messed up. So use them wisely as you need. Finally, back to our fragment. Since we want to make it display the widget when it's played on the graph, so we gotta override pre-node begin play event. Next, place dialog widget fragment here. There we go. And break it. Get the node reference, resolve, cast it to df dialog widget, and get dialog widget from this. Great, so now we have the widget, and now let's go to the widget and see where could be the best place for our new widget. Go plugins, joint native, widget, widget blueprint, dialog widget. Where to put your widget is up to you, but I think it's best to put our widget on the internal layout vertical box. So get internal layout, add child, and now create the widget and plug it. Well, we don't have the widget blueprint to add at this point, so let's make that. Create widget blueprint and give some style. Just add one text block and two buttons. That's enough, just don't cook it so hard. So there we go. And go to the graph and add on-click event for the both of the buttons. And one will be used to spawn new apples, and one will be used to tell the apple fragment to finish itself. For that, let's make this widget take df apple we made, make a new variable and name it df apple, and change its type to df apple. Of course, mark it instance editable and check expose on spawn. Great. Let's start with add apple button, place our fragment reference, and call event spawn apple and connect it. And next, for the finish button, well, we need another event that will tell it finish. So go back to our fragment, add new event, name it finish, and attach mark node pending if needed. Since it will not have any subnode, so it will end immediately. So go back to the widget and call finish there. Good. Lastly, let's update the text block with the current apple count. Apple box actor has a property for the current apple count called apple count, so just let's use that. Then it's done in the widget path. Go back to our fragment, specify our new widget blueprint on create widget function, and feed self-reference to df apple property since we're in the fragment. Then it's done. I also wanted to make it spawn 10 apples when it begins, so I just added that part as well. One last thing to do, I want to close the widget when this fragment is marked as pending, but I don't want to leave it there until whole foundation node ends after this node finishes its task. So let's just store the widget and override post node marked as pending, and put a logic to remove the widget from the parent. Then it's totally finished. Well, it's kind of additional thing, but kind of important to know. In this tutorial, we added our slate directly to the widget without modifying the dialog widget's blueprint logic itself. You can do this on the dialog widget side if you want, and it has its unique advantages as well. The way to do this is kind of simple. If you check out the dialog widget logic inside, you can see that it's taking many lifecycle related events from the dialog instance and updating the content of the widget from them. Especially if you check out the event on dialog node begin played, you can see how it is displaying each element on the slate. It works like whenever a new node or fragment gets played, it senses that and tries to cast that to each supported types and attaches widgets or does actions for that. For example, when it gets a text fragment, it grabs the text and text type table from it and display it on the screen. This approach has two big advantages. One is that you can make your fragment independent from the dialog widget class. This is kind of big for better project structure. And another is that you can reuse your fragments for different classes or also with different usages. It's especially important for the fragments that only contains data like text fragments. Now here comes the most important part. Yes, you're right. It's time to decorate our fragment. Just kidding, but it will help you to identify its fragments better, so let's do that real quick. First, you can just specify the display name, category, description of the node on the class setting. We are not gonna do much, let's just name it Alphabox. Really is all here, just go to the class defaults. If you check out the editor node category, you will find out there are some useful properties that will help you change the look of your nodes. You can set your node's body color, node icon as well, we call that iconic node. You can feed a texture or material as icon image, and also you can specify which level of slate detail your node will use by default. And let's see the results. That looks good. Alright, enough playing, let's test out our first fragment. But make sure to feed that Alphabox on the level to our fragment. And let's see. Okay, seems like immediately getting finished after initialization. So I checked out and it turned out the problem was caused by the default action of the post node begin play event. Since it calls mark as pending if needed by default, and since it doesn't have any children's fragments, so it's getting closed immediately. So let's override that event to suppress that default behavior. Check out the result again. Great, now it's showing the widget. Lovely. And also the add F button works well. And finish button also works as intended. So one is done now. And it's time to make that condition fragment that works with the F count of the F box. We are not going to start from the 0 at this time. Go to plugin, joint native, fragment condition, and copy that df condition is actor valid and paste it on our directory. And rename it as well. I will go with df condition FO has more FO than. So open it. Actually, it's kinda straightforward to understand. First, it resets variables for the condition test. Then it checks the condition. Lastly, it will play the next part according to the condition. Upper part for when it fails the check. Low part for when it's failed. Well, when it's passed, it will play subnodes and try to mark itself pending if needed. And when it's failed, it will skip playing subnodes and mark itself as failed and pending immediately. And what we have to do is kind of very simple. We don't have to change the first and last part and only need to change the middle one. Well, it actually do the condition check. For our condition check, let's add a dialog node pointer variable for the F fragment. Also add an integer variable to use it as the goal count. Now let's make it check the F count of the F box on the level. F fragment, break it, resolve reference, and cast it to df F. Get F box, resolve it and get F count from it, and compare this with our goal F count. Plug it to the branch node, then it's ready. An important thing is you make sure to handle all logic branches like this, otherwise it will stay active forever, which is not desirable in any situation. Also, one last thing to do, update the part where it resets variables, delete existing get class default node and place it again, because it will refer the class defaults of the original node where it has been duplicated from, which can be problematic. Let's quickly change the name and description of it, and place it on the branching fragment, and pick our F fragment on here, set the goal count to 40. Now it's time for the finale. Add apples with the button. When it's less than the goal count, it will say no, and let's spawn it until we hit 40. And there we go. Congratulations, now you've learned how to make new fragment and how to control gameplays with fragments as well. And we have the final one last fragment sample to see together. We have df format text player attribute fragment here. And this is a fragment that automatically formats any known attributes in the descendant text fragments. For example, arguments like player money, player stats, charisma will be formatted with the data we want. Yeah, this is remarkably handy and practical one. And it's very simple actually. What it does is simply grabbing all text fragments under itself, and formatting their text, and replace the original text in runtime. And to achieve that, you must grab all the descendant text fragments under this fragment. And for that, you can use find fragments or get fragments family functions in your fragments to quickly grab the children fragments or descendant fragments to use or manipulate them. Well, plus, if you need, you can use get parent node function to get the parent and use it as you need. If you play this, you will see it's formatting all the text fragments, even some in the select fragments as well. So, you can now try even more dynamic and amazing things with your fragments. Joint will open your wing for you, so just go ahead, play free with it. One very last concept for the system. This one is easy to understand and will not request you to follow along, so just stay chill and listen to. Joint supports responsive production even after the localization, and it comes along naturally with the modular framework design. For the explanation, let's assume that we have to play an animation and sounds together for a character. We play those in timeline-based playback system such as level sequencer. Obviously, it will have no issue in original culture, perfectly timed for voice track. But what would happen if the audio file's length gets shorter after the localization? That it will be out of sync and have very awkward results. But in Joint, since we can make things as module, we can control the timing responsibly, unlike the timeline systems. For example, in production like this, the total length of the animation will be adjusted according to the sound's changed length, so the length of the sounds doesn't break the sync of the production at all. Or you can even make both fragments stop when any of the nodes stop, so ensuring they will be ended at the same time. This is the key of how Joint could easily achieve perfect responsive production even after the localization. And this responsive production feature also works in the networking environment as well. The way it achieves that is kinda simple. It just let all the clients play their fragments as they want. It allows the dialogue production to be perfectly specialized to each client, and while doing that, we made only the server, well, more specifically, session with the authority over the dialogue instance. We made only that one can move to the next foundation and other clients to follow that, well, to match the timing of the overall playback. Oh, by the way, don't worry about it. If you want, you can still strictly synchronize each fragment's playback with some additional fragments. Think about something like planting a custom wait skip fragment but without explicit skip action after every fragment that needs hard synchronization, so they will do the trick. And if you need to play some logic that must be replicated to the clients, not just mere timing but whole thing, well, you can just do it in the server side with the fragment like on server and make it replicate that action. For example, if you want to make all players see a level sequencer together, then it must be done in the server side and you can do it with that. If you look at further explanation or sample assets for such things, I will upload tutorials on the official documentation page, so let me know if you need that. So, thank you for listening and see you soon.